everyone, welcome back to the channel Non-Star Continuous Knowledge Excellence. My name is Karuna Singh. A very special guest has joined us on our show, Dr. Somanchi Krishna Murthy, Defense Institute of Advanced Technology, Deemed to be University, funded by Department of Defense, R&D, Pune, India. Welcome, sir.
Good afternoon, ma'am.
So, first of all, just tell us something about yourself, about your experience.
So already you introduced me, then I'm Professor Murthy. I have completed my post-graduation from Osmania University and Osmania University, Hyderabad, and my doctoral degree from the Indian Institute of Technology, Kanpur. And subsequently, I have been offered a postdoctoral position under Erasmus Mundus Fellowship to École Centrale Paris. And I'm currently working as a professor in the School of Computer Science, Computer Engineering and Mathematical Sciences, Defense Institute of Advanced Technology, which is a deemed university. So funded by Ministry of Defense R&D, so which is located in Pune. And my current research interests are mathematical modeling, finite element analysis in fluid flow through porous media, and numerical methods for partial differential equations, and numerical parallel algorithms, and the computational fluid dynamics. This is about myself.
Okay, let's move with the questions. So, if I talk about the thermal energy, right? So, what is the importance of thermal energy in today's world?
But it's difficult to explain the entire meaning of this thermal energy and its applications and today's world applications. But briefly, I will try to explain.
It's a very vast term.
So thermal energy, since these days, which we heard about our higher school studies, and which is our nature surrounds in our usual everyday. So from our morning cup of coffee to the methods which we use our regular applications like power home appliances, etc. So thermal energy is a part of our life, which whether we realize it or not. But as a thermal energy means, thermal means we need to think about the heat. So what is the importance of heat in our daily life which we are mentioning or we are talking about now? As a simple applications, as I mentioned in the above everyday life, which is one application is called cooking. So heat is required for cooking food, and cooking food is one of the necessities in our life. And another example is called warming. So in winters, heat is important for providing warmth to the house and warming water. And engines, so various engines such as rail engines works on heat. So electrical appliance, like all electrical appliances need heat. So generate electricity. So heat is used to generate electricity. So all these are all the simple applications which we are seeing in our daily life. So heat means is a thermal. So when how it has come, who has proposed this? It is called James Joule has proposed in the 1850s. This is a theory of radical theory that energy takes from different forms. So including heat. So and these forms of energy were interrelated, which is supported is his idea by providing the heat has mechanical equivalent, and the two could be converted from one to the another. But another, this is measured in SI units, it's called joules. And in the British thermal units is also that we call it as BTU, so which is also measured in this. So 1 BTU is of the quantities of heat required to heat 1 pound of water from 39 degrees of Fahrenheit to 40 degrees Fahrenheit. So it has various types of energies in applications like geothermal energy, ocean thermal energy, etc. But they have wide applications from the industrial scale down to the individual personal level. Like all batteries, fuel cell batteries have an electrode and cathode. But hydrogen fuel batteries rely on the electrons from hydrogen molecules to create a flow of electricity. However, manufacturing costs, lack of infrastructure, and high price of hydrogen means batteries remain a fledgling industry. So, but thermal energy efficiency, how it is important, how we can achieve it, is another important challenging job, which is. So, in addition to this, hydrogen energy flammable and is California study says that and change to 250,000 charging stations for vehicles using hydrogen fuels by 2025. This is one of the practical example of the thermal energy usage for the future. And we are talking about thermal energy. But first, what is thermal energy? So thermal energy storage means heating or cooling a medium to use the energy when we need it later. So it's the simplest form, but this could mean using a water tank for heat storage, where the water is heated at times when there is a lot of energy, and the energy is then stored in the water for use when energy is plentiful. So thermal energy storage can also be used balance of energy consumption between day and night. Storage solutions include water RO storage tanks of ice slush, earth or bedrock accessed via boreholes and large bodies of water deep flow of the ground. One of the major user today is buildings, with a contribution of about some 50 to 60% of end user energy consumption. So in terms of energy usage, a building's heating and cooling is the most energy intensive activities, followed by electricity consumption. With expanding urbanization across the globe, the demand for residential and commercial buildings is only going to increase. And hence, energy consumption in buildings can only be expected to go up. The increase in need will in turn create a burden on local resources and ecosystem. Hence, with an increased investor and consumption demand for eco-friendly and to cost-effective building materials, the construction industry has to look into sustainable energy to improve energy efficiency in buildings. But what need to be done for accelerate thermal energy storage? A regulatory framework should support the creation of decentralized energy systems that encourage systems integration and use of waste heat pumps, smart heating and cooling systems, and energy storage. And we need to ensure that electricity prices reflect the energy mix to encourage and uptake of renewables, for example, through CO2, carbon dioxide pricing. So you must ensure that power price incentivizes or rewards energy storage. For example, electricity should be cheaper when there is a lot of renewable energy and more expensive when there is not. And it should be attractive to store and sell back energy to the grid. These are the some importance of energy storage and its applications which required for the future.
Yes. So, what are industrial finite element method codes and how are they used in structural engineering?
So, before we talk about the industry and etc., first we should know a little about the finite element methods. It's difficult to explain the entire finite element, but the importance of this is coding point of etc. So, finite elementals use the uses of calculations, models, and simulations to predict and understand how an object might behave under various physical conditions. So engineers uses finite element analysis to find vulnerabilities before proceeding for the prototypes. So finite element analysis uses for the method for numerical techniques that cuts the structure of an object into several pieces or an elements, and then reconnects the elements at points called nodes. So the FEM creates a set of algebraic equations which engineers, develops, and others designers can use to perform finite element analysis. So frequently, the physical experience of a product, such as structural or fluid behavioral and thermal transport, are described using partial differential equations. But finite element analysis emerged as a way of computers to solve both linear and nonlinear PDEs. However,
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in where you can easily enroll in the workshops. So just check it out right now.
it is important to note that finite elements only provide an approximate solution. It is a numerical approach for finding real results, partial differential equations. So using finite element analysis can reduce the number of physical prototypes created and experiments performed, while also optimizing all components during the design phase. So finite element analysis software emerged in 1970s with programs, and now it is common to find virtual testing and design optimization integrated into product development cycle to improve the product quality and reduce the time to takes into entire market. So it types various different types of such finite elements of test, right, like structural statistical analysis, thermal engineering analysis, model analysis, and engineering seismic calculations, etc.
How seismic engineering is used to make earthquake resistant structures.
Yes, ma'am. Just now I mentioned that engineering seismic calculations is above finite element. When it comes to that, seismic engineering has evolved over a period of time. The complexity of analysis is used to contain numerous iterations of formulas. How we have been automated with tools like ETAPS, STAT, ProRobot, Tekla, and others. So these tools results advantages outcomes, including but not limited to safe, stable, and durable structure, along with optimization of design and cost efficient structures. So, like another example, hospital and educational buildings are special structure with a high importance factor ranging from 25 to 50% analyzes score than residential or commercial structures. So, seismic resistance of building can be increased by adapting different types of structural systems like seismic isolation systems, energy dissipation system, and active control system, etc., which enhances the seismic behavior of a building by dissipating the lateral forces without damaging the structural elements. So these buildings made withstand earthquakes may not look remarkable form from outside, but however, numerous aspects make them more reliant during these disasters. There are five elements which we can think about is an appropriate foundation to be taken care, and the seismic dampers. What is the seismic dampers means? Earthquake resistant buildings also need features to help absorb shocks. So people more commonly refer to them as seismic dampers. So a drainage mechanism and a structural reinforcement and material with adequate ductility. So if you taken care of these five elements, yes, we can take care of the seismic engineering.
Okay, so as you are the editor in many of the mechanical journals, fine. So what will you say about the importance of research writing, about the research?
This is your, you can go through my papers which have published currently, as I mentioned in the above, my area of research in fluid flow through porous media and finite element analysis, and which papers we can refer, which recently published in the physics of fluids, that is, and also International Journal of Heat and Mass Transfer, and International Journal of Mechanical Sciences, which is called Entropy Generation in Chemically and Thermally Reinforced doubly stratified porous enclosures, and in the International Journal of Heat and Mass Transfer, that's influence of the magnetic effects by considering the Bijan's heat line mass lines. It's a numerical study by using finite element, and the similar kind of work to understand the multiple forces acts on a convection porous media, how you model and how you solve the by using finite element analysis, which published in International of Mechanical Sciences, which are my recent publications. However, we can go through many research articles of my profile. So that gives the clear idea of my research area for.
Okay. Any message which you want to give to the students who are pursuing mechanical engineering? I mean, what is the importance and what are the career opportunities? So that, yes, I have to choose mechanical engineering. So why should I choose mechanical engineering?
This is the mechanical engineers that you talk about. The structural engineers work across the various industries. Applications are there. That is from building to manufacturing, and the design and oversees the construction of buildings, bridges, and other major infrastructure projects. So their role is where you will combine your analytical thinking and the creative outlook to bring inspiring projects to life. So that diversity means there are many different career paths. You can take it as a structural engineer job or the mechanical engineer, and As a structural engineer, we can say structural, senior structural engineer, construction design engineer, project management, research, and lecturing. So these are the areas we can explore. And mechanical engineer have vast applications. Kind look into that.
All right. Thank you so much, sir. Thanks for your time. And it was really a very, very nice interaction. And I would like to suggest to all my viewers to subscribe to the channel for more informative, educational, and these type of videos. And hit the bell icon too to never miss an update.
Thank you, ma'am.
Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.